Before we start looking at what temperature is in the context of large language models, let's diverge a bit and see how change in temperature can produce some very interesting physical phenomena. Let's take the example of a water boiler. At a low temperature, the water molecules inside the boiler behave in a slow, regular, and predictable way. As the temperature rises, the motion of the water molecules becomes irregular, leading to turbulence and highly unpredictable and random fluid patterns. In short, increase in temperature means moving from a stable, predictable state to a more chaotic one. Let's keep this analogy in mind while we switch over to the context of large language models. Temperature is a way to control or tweak the behavior and output of a language model. The technical term for these kind of controls is hyperparameters, which was introduced in one of our previous videos. In simple terms, temperature controls randomness in the output of a language model. Lower temperatures result in less random completions that might appear repetitive, while higher temperatures will result in more random output. For example, when temperature is close to 0, the same input prompt will result in the same answer at all times. The label phi3 in the diagram refers to the name of the language model that we tested. When we increase the temperature and try the same input prompt, we will get different results each time. The way that temperature works under the hood roughly corresponds to the probability values that are assigned to the group of predicted next words or tokens. At a low temperature, the word day gets a high probability value and thus becomes the dominant output. At a high temperature, almost all candidate words have the same probability of being accepted as the next word. This sort of randomness often leads to more varied, less repetitive, and creative outputs. For tasks where accuracy matters, a lower temperature is often the recommended setting. For example, when asked about the sum of two numbers, we want a more rigorous, accurate, and less random result. On the other hand, if we want our language model to act as an AI assistant and sound more realistic and human-like, we prefer a high temperature that will result in more creative and less repetitive responses each time. And that's what temperature is in a nutshell. Thank you for watching, and make sure to like and subscribe to support our work. See you in the next video.